Now we're gonna find the area enclosed between these two curves. X is y squared minus 2 and x is 2 minus y squared. Notice here the difference. We used to integrate for functions that depend on x. These ones depend on y. Okay? So we can transform these ones in terms, we can write y in terms of x, but this one is going to be tedious. Okay? And it's good for us now to learn something new. We can graph these functions. Okay, so this first function is this one here, 2 minus y squared. Now let me write this one here, 1, 2, minus 1, minus 2. So this one is just minus y squared shifted to units. Okay. Okay, this is 2 minus y squared. The other one, y squared minus 2, is just x equals y squared shifted to units. Okay, now if we try to integrate with, so let me see, this is minus 2, this is 2, this is minus square root of 2, and this is plus square root of 2. Yes, when x is 0, y is 2 or minus 2. Okay, so we want to compute this integral here, the area enclosed between the two. If I try and integrate with respect to x, okay, I'll see that they have the same function. Okay, so this is which one is I have to subtract from the other. I need to write this one here, and an expression for this one, an expression for this one. And I need to subtract them to get this one here, the rectangle. Okay? Very difficult. In general, it's easy in this case here. We can do it. But in general, it's difficult. Here, for the y, if I want to integrate with respect to y, I see that I have my function here, this one here, on top of the second one here. So I can integrate between minus square root of 2, square root of 2, of this function on the right or on top, which is 2 minus y squared minus y squared plus 2 dy. Since this one is even, I can even simplify this one as 2, the integral between 0 and square root of 2, or I can do more. I can take 4 minus 2y squared dy, which I can simplify more as 4, I take the 2 outside, between the integral between 0 and 2 of 2 minus y squared dy. Okay, and this is easy to integrate. Instead of working with the integrating with respect to x, I can do the integration with respect to y. Okay, so here I have this function. This is my f, this is my g, and this is my dy. And I can integrate. Therefore, I can integrate here. I can get 4 2y minus y cubed over 3 between 0 and square root of 2. I get 4 2 square root of 2 minus 2 square root of 2 over 3. And if I want to simplify, I get 4, let's multiply by 3. I get 8 2 square root of 2 minus 2 square root of 2 over, no, I multiply by 3, sorry, I get 6 over 3. So I have 4 times 4, 16 square root of 2 over 3. Let's check one more time. 4, 6. Yes, this is my area. So instead of integrating with respect to x, sometimes it's good to integrate with respect to y. Okay. If we if it's too difficult for us to integrate or to see, there is another trick that we can do. Okay, so x and y are just a simple variables. Okay, we can switch everything to x. Okay, we can flip this graph. Okay, and we can treat it as 2 minus x, 2 minus x squared is this one, and x squared minus 2 is this one. Now, to integrate, so what do I have here? Here, square root of 2 minus square root of 2, and this is 2, this is minus 2, this is 2. And I get integrate, I get the same area. When I do that, I get the same area. And what's my integral in this case? My integral is just between minus square root of 2, square root of 2. Which function is on top? It's 2 minus x squared minus x squared plus 2 dx. And I get the same area. So don't be fooled by this one here. Okay? Sometimes you can transform the whole problem, or maybe make a rotation of 90 degrees, and you will see something that will help you and simplify the computation. Okay, so I was explaining, I didn't check this one, I may have made some mistake, but the idea is that even if something that's very difficult to integrate, we can either integrate it with respect to y or vice versa. Okay, and this ends our video. Thank you very much.